Hi everyone and welcome back. So today we're going to be talking about rational and irrational numbers. So first thing as we get started is we need to have those definitions down. So rational numbers, and again this should be somewhat of a review for you. So rational numbers are numbers that can be written as a fraction of integers. Now, contrary to a rational number, are irrational numbers. So irrational numbers, they're just not rational. So they cannot be written as a fraction of integers. Okay, it's a number that doesn't terminate or repeat. So another way of saying a number is irrational is if it's non-terminating or non-repeating. Okay, so if we have a number as irrational, that means it's non-terminating and non-repeating. So non-terminating means that it never ends and it doesn't repeat. Okay, so some examples I put here were like the square root of 3, pi, a decimal number that doesn't end or repeat. Rational numbers could be integers, fractions, and decimals that do have a final point or they repeat. So if I start with some examples, we're going to determine whether it's rational or irrational. So if I have a number 2.56, well, the number 2.56, is it repeating? No. Does it go on forever? No. So this is something that's rational. I could actually write this if I wanted to. If I went to math frac in my calculator, so if I clicked math, frac, enter, if I typed this number in, I could actually write this as a fraction of integers. So this is rational. It can be written as a fraction of integers. Now for the number 3.1415926 blah, 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 as you can see, there is no pattern. So there's no pattern, and this never ends. So we would say this is irrational. There's no pattern, and it never ends. It's non-terminating and non-repeating. Now, again, if we take a look at now the number 1/3, well, 1/3, 1 is an integer, 3 is an integer, and it's a fraction. That's a fraction of integers, so this is rational. Okay, let's take a look at the next one. Now I have 0.3 with a bar over it, so that bar means it's repeating. But now, does anyone actually know what 0.3 repeating can be written as a fraction? If I typed in my calculator 0.33333 a bunch of times and went to math frac, enter, it's actually going to be the fraction 1/3. This is the same thing as the fraction 1/3. But we should also be able to tell that this is rational despite that fact because there's repetition in this decimal. This is 0.3333. It goes on forever. There's repetition. Remember, to be irrational, it has to be both non-terminating and non-repeating. But this repeats. That's good. So this is rational. So we can write that as a fraction of integers. Okay, and then the square root of 12. Now this is something I would be typing directly into my calculator. So when I type square root of 12 directly into my calculator, I end up getting 3.464101615, and it keeps going. Now, as I look at this number, I notice I don't see any kind of repetition or termination to this number. It goes on forever, and there's no pattern. So by default, this follows our definition that this has to be irrational. The reason for this being is because it's non-terminating and non-repeating. So I'm just not going to recopy that, but it's the same definition here, same explanation. Okay, let's take a look at question 6. I'm going to do part A plus B, and you're going to do B plus C. So we're going to add, I have the square root of 5 plus I have the square root of 9. Now, we should start to get recognized with our perfect squares. I noticed that 9 is a perfect square. If I wanted to, if I just typed into my calculator, the square root of 9 is 3. Square root of 5, not so nice of a number. I end up getting something like 2.23606797 plus 3. So now if I were to add those numbers together, I get 5.23606797, and it keeps going on. So I had a rational number here. There's my rational number, plus a number that's going on forever. Well, when I added a rational number with an irrational number, our result is still going to be irrational. And the reason being, why do we know this is irrational? Because it does not terminate and it doesn't repeat. All right, and you're going to do B plus C for me for practice. So let's keep going. We're still on page 6. So we have J states the product of the square root of 2 and the square root of, 3 times the square root of 2 is irrational, since radical 2 and 3 radical 2 are both irrational numbers. We want to know if he is correct or incorrect. Well, now, I do want to make a point, and I'm going to write it over here, just for lack of space reasons. This is not the answer to B plus C. I want to just note that we said an irrational number plus a rational number was irrational. Okay, that's a fact we know. So let's take a look down here. Is the product, we have to remember the word product means to multiply. So when I multiply radical 2 times 3 radical 2, well, let's see what we get. I'm going to type that directly into the calculator. I end up getting 6. So is it necessarily true that an irrational number times an irrational number is irrational? That's what this is saying right here. Is that true? Because our answer was 6. No, this is not true. An irrational number times an irrational number does not mean it has to be irrational. In this situation, we had an irrational times an irrational is rational. So J's statement is wrong. Even though we multiplied 2 irrational numbers together, we still got a rational value. Okay, and then there's just our explanation written up. Alrighty, so I'm going to move on to the next page. So let's turn over to the next page. That's page 7. And now I do want you to know question 8 comes directly from Regents as well as several others on this page. So let's get started with question 8. We'll do this one together. Okay, so we have which of the following expressions is going to result in a rational number? And we have all the values given up here. Okay, well, you guys should recognize again, and we're going to do this in a separate lesson if it's not obvious right now, we should recognize what our perfect squares are. 2 is not a perfect square, 3 is not a perfect square, but 16 is a perfect square. This really is, square root of 16 is really just 4. Square root of 9, 9 is also a perfect square, so I'm also just going to write this as 3. Okay? And then these other numbers for L and M cannot be reduced because they are not perfect squares. So these stay as is. So I just simplified these here. Okay, so let's just get started. L plus M. Well, let's see. I have L is radical 2 and M is 3 radical 3. So when I put this into my calculator, I end up getting 6.610365,985 ... And that is irrational because this number again is non-terminating and non-repeating. Let's take a look at M plus N. So I have 3 radical 3 plus 4. Okay, well now let's just type this into the calculator. And when I type this into the calculator, I get 9.196152423 ... keeps going. Now, you should have actually noticed, maybe you did, maybe you didn't. 3 radical 3, we already know, is irrational. So this is an irrational number. 4 is rational. What did we say before when we add an irrational number plus a rational number? What do we end up getting? What did we say earlier? We said this. This is a fact. An irrational number plus a rational number is irrational. So just from this information alone, 3 radical 3 is irrational. Okay, so 3 radical 3 is irrational, and the 4 is rational. Together, it will be an irrational number. All right, let's just keep going. We have n plus m. So I have n is 4 plus 3, and this is 7. And 7 is an integer, guys. It can also be written as a fraction of integers. If I really wanted, I could write this as 7 over 1. Or I could write this as 49 over 7. Okay, so there are a lot of ways I could write the number 7. So that's a fraction of integers. It's a rational number. All right, let's keep going. We have question 9. Are 4 radical 2 and 8 radical 2 equivalent numbers? Well, guys, I'm just going to put this in my calculator. What does 4 radical 2 equal? And what does radical 8 equal? Okay, so after putting this in the calculator, these are the values that I got. And very clearly, they're not equivalent. They're not the same number. So they're not equivalent. And I want to know, are they rational or irrational? Well, there is no repetition, and the number is going on forever. So this is irrational. We would say it is non-terminating and non-repeating. Okay, I want you guys to try questions 10 and 11 on your own. So that's your practice, and then we're going to do 12 together, and that's going to conclude our lesson. So after this is over, make sure you get to those colored questions that are in pink. Okay, so for question 12, we have the square root of 0.25 and 1/2 equivalent numbers. And are they both rational or irrational? Now, I wonder if maybe you do notice this, maybe you don't. Can you tell me what 0.25 is as a fraction? So think of that as a quarter, right? 25 cents. We can write that as 1/4, a quarter. So I want to take the square root of 1/4. Well, I already mentioned earlier, we got to get familiar with those perfect squares. 4 is a perfect square. What is the square root of 4? The square root of 4 is 2. And what's the square root of 1? 1. So the square root of 1/4 is just 1/2. So because the square root of 4 is just 2. So yeah, these are equivalent numbers. I have 1/2 is equal to 1/2. And I want to know, are these both rational or irrational? Well, 1/2 is a fraction of integers. So this is rational. Okay, now I am going to give you just a little bit of a head going into our next lesson information. So I'm just going to write this at the bottom of the page. It's up to you wherever you want to write it. I just want to write down our perfect squares. So I'm going to write down the square root of 1 is 1. Square root of 4 is 2. The square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. Square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. And the square root of 100 is 10. So now I can keep going. There are infinitely many. I'll just include maybe just a few more. The square root of 121 is 11. And the square root of 144 is 12. So be on the lookout for that in tomorrow's lesson. We need to become very familiar with the perfect squares. I really want you guys to get very comfortable with them and recognizing them when you see them, all right? Hopefully you found this video helpful, and we will talk soon.